Welcome to video 7.2c. Use the no choice theorem in a proof. Alright, this is example 4. I'm skipping example 3 to keep the video length lower. Alright, given, and I'll mark things up, AC is parallel to XY. And again, for me it helps if I extend those parallel lines. AB is parallel to CY. Again, it helps me if I extend those parallel lines. So I'll just mark it up like so. And angle ZAC is congruent to angle XAB. Angle ZAC congruent to XAB. All right, prove that angle X is congruent to angle Z. All right, so I give you a hint. We're going to be using the no choice theorem here. So it looks like these are angles in a triangle. So I don't need to get the triangles congruent, but if I could possibly get two pairs of angles congruent, I can get to the third pair. I've already got this pair here, so really, if I could somehow get this angle to be congruent to that angle, then I would be able to get my ultimate angles congruent. So now this becomes my focus. And with parallels, usually I've got alternate interior corresponding, things like that. So let's see if we can make that happen. So right now I'm going to be thinking out the proof. This angle and this angle, this line and this line are parallel. So I will be able to get that angle congruent to that angle. And then I've got a parallel here and a parallel here. So this angle and this angle are alternate interior. So then I can use transitive to get this one to that one. And now that's going to be the way I'm going to do my proof. So let's put it down. So I'll start with AC. It's parallel to XY. Given. Now based on that, that's how I got these angles here. So I'll call it angle XBA is congruent to angle, I'll call it BAC. If parallel, then alt interior angles congruent. Okay. So then I'm going to use the other parallel. AB is parallel to CY. That was given. And again, if AB is parallel to CY, then I'm going to have these being the alternate interior angles. So again, I'll call it angle BAC. Is going to be congruent to angle, I'll call it ACZ. If parallel, then alt interior angles congruent. Okay, so ultimately what I want to try to do is get those two to be congruent. So I could use some transitive now. Let me just show you how that's going to work. I've got this listed twice. That's going to be my in-between. So this angle goes to angle BAC, and then angle BAC will jump to angle ACZ. So angle XBA is congruent to angle ACZ by transitive. And then I was given these angles, I'll just list those right now. Angle ZAC is congruent to angle XAB, that was given. So now, based on those two angles being congruent, I can use the no choice theorem to get the other angles. So angle X is congruent to angle Z. No choice theorem. So there you have it. How to use the no choice theorem in a proof.